Welcome back to Introduction to Trigonometry. Put your thinking caps on today because we're going to expand your knowledge from last time. Remember, last time we covered the angles. Basically, we limited our discussion to the angles of a right triangle, which really limited it to either the 90-degree angle of the right triangle or the other two, which had to be less than 90. Okay? Well, there are other angles in this world, and that's what we're going to talk about today. Everything else, all other angles. Okay? And what are they? Angles perhaps more than 90, angles more than 360 even. Okay? And we're going to talk about another way of measuring them. Remember last time it was such a nightmare. I was worried about that what mode we were in. We're in degree mode or radian mode. Well, we're going to talk about that. What is radian mode? What does that have to do with anything? Another way to measure things. Okay? And of course, as usual, we'll talk about the applications of all these. And in addition, how we can use the calculator to help us with that. Okay? So let's take a look at some of the more common vocabulary so that you'll know what I'm talking about as we go. Okay? There's really four types of angles that I'm going to be talking about. Two of them you should probably already know. Okay? If we have a corner that looks like this, I bet you already know. Okay? The mouth opens that way. And it measures 90. Okay, we get used to that. We call that, what do we call that? Before we called it a right angle. And to signify that, we're going to draw a little square. Okay, so when you see the square, you know it's a right angle, not 89.9 or something. It's a 90-degree angle. Okay? Other ones we talked about before, what if it's smaller than 90? Okay, it looks something like this. And how would it open? The mouth would open like that. Okay? And that's definitely smaller than the 90. It's not opening as wide. And that's called, it's between 0 and 90. That's called an acute angle. Okay, I remember acute because it's cute, it's small. Okay, now other words that we haven't introduced yet are what if it's more than 90? Okay, well this specific word doesn't just mean any angle that's more than 90. It has to be more than 90 but less than 180. Okay. It's going to open this way. It looks something like this. It opens wider than 90. Okay, so it's between 90 and 180. The word is obtuse. Okay, it's large. It's obtuse. Okay, and if it makes it to 180, it's a very special angle. Makes it to 180. It's going to look like that. It's going to be a straight line. Really, that's what a 180-degree angle is, and it's going to open up that kind of in that direction, and it's going to be exactly 180 degrees. We call that a straight angle, known downtown on Friday nights as a line. Okay? Okay. Other words that I'm going to be using are, I think we talked about complementary angles last time, but now we're going to add that to that, the word supplementary, and they're similar. Okay? What are complementary angles? Well, things to complement each other, it takes two. Okay? By the way, not three, two. Two angles are complementary if they add up to 90. That's what it means. They add up to 90. Well, what does supplementary mean then? Well, what's the other special number that we know of? Well, they're supplementary if they add up to 180. Okay? So complementary if they add up to 90, supplementary means they add up to 180. Why do we care about this? Because if they add up to 90, think of a carpenter is always trying to make a corner. Okay? So, and that's what 90 would be. You're trying to cut two pieces of board in such a way that when you put them together, they're going to form a perfect corner, which is hard if you're a carpenter, I can tell you. And what's so important about supplementary? Well, in that case, we're trying to form a straight line. We're trying to make something flat, okay, which, again, is something in carpentry and building that you're going to want to do, okay? So the words complementary and supplementary you'll need to know. Well, let's make this more difficult. What if I asked you, what is the complement of 56 degrees? And I'm going to throw another question in there. What's the supplement of 56 degrees? Okay? Well, if I wanted to find the complement of 56, that means I have to subtract 56 from 90, because that's what complement's all about, subtract it. So let's subtract that bad boy. Well, this is pretty simple because there's no carrying in this case. Okay? I'm writing it in a fancy language to get you used to it. Remember those little symbols? The degree is the circle, and the next thing is minutes, and the next thing is seconds. Okay? Remember that a minute is 1/60th of a degree, and a second is 1/60th of a minute, thereby being 1/3600th of a degree. Okay, so let's do this subtraction. This one's not too hard. Okay, because 0 minus 0 is 0, 0 minus 0 is 0, and 90 minus 56 is 34. Okay, so the answer is 34 degrees, 0 minutes and 0 seconds. That's the complement of 56 degrees. What about the supplement? Well, the supplement's going to be the same deal, except we're going to subtract it from 180, okay, instead of 90. Well, let's do that. Subtracting it from 180, don't have to do much carrying. 0 minus 0, 0 minus 0, 180 minus 56. If I do that subtraction, I get 124. So the supplement of 56 degrees, the angle that you would add to 56 degrees to get 180 is 124. Okay? And we're going to do it much more difficult than this. Let's talk about this with something we talked about last time, minutes and seconds. Okay? What if I want the complement of 56 degrees, what is it, 23 minutes, 16 seconds. Now, and there might be carrying, so don't be a baby. Okay, let's see. We've got to subtract this. Here's where it gets difficult. We have to subtract it from the 90 degrees. Okay? How are we going to do that? Well, we can't go, we'll start at the right side, we can't go 0 minus 16. Okay, so we'll have to carry. We'll have to draw, we need a couple more seconds, if you would. So if we pull a second away from a minute, we get 60 of them. But I don't have any to pull away from, so I have to pull a degree away, and if I pull that away, I get 60 of them. Let's take a look at it. I'm going to cancel this out, and I'll have 89 degrees, because I pulled a degree away. And I'm going to pull a minute away, and that'll leave me with 59 minutes. And if I pull that minute away, a minute away, the second, I'll have 60 of them. Okay, now I can subtract 60 minus 16, the 59 minus the 23, and the 89 minus the 56, and I get an exact answer. The complement of this 56 degrees, 23 minutes, 16 seconds is 33 degrees, 36 minutes, 44 seconds. Okay? I'm going to do the same thing, just in case you missed it, but we're going to do it with supplement. So now what's the difference? We're subtracting from 180 now. Okay? Let's subtract the same angle from 180, and we still have the same nightmare. I was trying to be nice here to give you the hardest possible problem so that when you get to the homework, those will be easy. Okay? Once again, I have to carry. If I take a degree away from 180, that leaves me with 79, thereby giving me 60 minutes. But I need seconds, so I'm going to take a minute away from that and have 59 of them, and giving me 60 seconds. So now I can subtract 60 minus 16, 59 minus the 23, and the 179 minus the 56. And that's just basic subtraction, and I get an answer, which is the supplement. Okay, the angle that you would add to get 180. It's very exact, 123 degrees, 36 minutes, 44 seconds. That's as hard as it gets, so don't worry about that. Let's try doing it with a calculator. That might be a little bit easier. Okay, I'm going to first show you how to do it with the TI-83, then we'll do it with the TI-82, because they're a little bit different. Okay, we're trying to find the complement of 56 degrees, 23 minutes, 16 seconds. We already know the answer, but let's do it. Hopefully it'll be easier with the calculator. Okay, let's look at this calculator. I'm going to try to get the complement of 56 degrees. The first thing I'm going to do is make sure that I'm in degree mode, okay? Actually, the first thing I'm going to do is turn it on, okay? Okay, let me clear out, and I'm going to go into mode and make sure that I'm in degree mode. Remember how to do that? I can see that I am, but you would cursor down, go over to degree, hit enter, and then clear out, okay? Just want to make sure that I'm there. Okay, now I'm going to subtract that angle from 90. Oh, the calculator is going to do that for me. Okay, so I'm going to put in 90, and I have to say degrees. You say, well, geez, why do you have to say degrees when you're in degree mode? Well, you have to say it's a degree as opposed to a minute or a second. Okay, so that's why you have to do it here. Okay, so let me get to degrees. Remember how to do that? It's in second angle, and there's degrees. I hit the 1 or hit enter because I'm already on it. Okay, and I'm going to subtract out 56 degrees. 56, I have to put the degrees, second, angle, 1 or enter. 56 degrees, 23 minutes, 23, second, angle, Now here's the minutes, the 2. No, note, by the way, while we're in here, there is no seconds. Okay, so we're going to do that next. Okay, and we got to get the 16 minutes, or seconds, I mean. Okay, now where is that? Remember how to do that? You do that on the alpha key, which is right below the second key, and then there's quotes down on the bottom right of the calculator, which are green. It's right above the enter key. Okay, and I'll subtract that. And let's see what happens when I get an enter. I hit enter and I get an answer. That's the correct answer, but that's the answer as a decimal. Okay? Would you like it to, perhaps you'd like to see it, and this is a review from last time, in degrees, minutes, and seconds. Okay? Well, we can do that, and I can type the whole thing out, but I'm too lazy to do that. I can bring that 33.61 blah, blah, blah up by hitting the answer button, which is second, and then down the bottom right where it says A and S, or answer. Okay, right next to the enter key. Okay? And that, it says take that answer, and I want to put it in DMS, or degrees, minutes, seconds. So I'll go second, angle, and there's your buddy down here. See it? Degrees, minutes, seconds. Hit enter to get out, and I guess I have to hit enter again to change it. And hi, Mom, I knew the answer was 33 degrees, 36 minutes, 44 seconds already, but the calculator did it for me. Okay? Now let me give you a chance to do it. Okay? Let's go back to the full screen, and we can see that the way to do this, remember what we did. You try it with your calculator. You went into mode and made sure you were in degree mode by cursoring down and then clearing out. Okay? Then you hit 90, and you had to put degrees. So you went second, angle, degrees. Okay? And as soon as you did the 1 or the enter, it came out. Then you have to subtract. You have to put in your 56 degrees. So 56 second, angle, degrees. You got to put in your 23 minutes, so 23 second, angle, minutes. And you put in your 16 seconds by going 16 alpha, down the bottom right, quotes, or seconds. Okay? And you hit enter, and you get a decimal. Okay? Some nightmare. Okay? Now, if you want to take that decimal and convert it, just let's do it for practice, you can hit second answer. That saves you from typing it again. And we have to tell it we want degrees, minutes, seconds, DMS. Okay, so we hit second angle, and it gets you into the little catalog where you can see all the different functions. Go down, I think the fourth one down is the DMS. Okay, and hit enter, and that puts the DMS, and then hit enter again, and you get the answer. You're looking good. Okay? Now, how is that going to change with a TI-82? Okay, I want to find the same thing with a TI-82. Let me do it. Of course, this is a TI-83. Okay, but just in case you have a TI-82, let me show you the steps that you would do. I'm going to pretend this is a TI-82. Okay? I think it's important. Okay, so once again, I'm going to subtract. I'm going to put in 90. And I'm going to subtract, but I have to say degrees. But on a TI-82, you don't do degrees. You do second, angle, and I guess they're thinking to make it easier, you only do the minutes every time. Okay, it's supposed to know the order. Okay, so I'll go to 2, and I'll say 90. That's really degrees as far as a TI-82 is concerned, and subtract out my 56, which will be degrees, but I'm going to put minutes. Second, angle, cursor down to that. Okay, 56 degrees, 23 second, angle. Only got to do the same thing every time, right? Okay, and the 16 second, angle, and come down here. Okay, and that's the way you would do it on a TI-82. Okay, this is a TI-83, so I'm going to get an error, so bear with me. Okay, and I'll clear out. Okay, let me give you a chance, you TI-82 people, to do it if you'll go full screen. Let's take a look. First thing, as always, we'd make sure that we're in degree mode and then clear out. So mode, degree, and then clear. Okay, probably already there because you were there before. Okay, you'll put your 90, and second angle, and the apostrophe, or what we would call minutes, we TI-83 people, minus 56 second angle apostrophe, 23 second angle apostrophe, 16 second angle apostrophe. Okay? And if you hit enter, you're going to get your decimal. Okay? Now the rest of it is the same. If you wanted to change it to DMS, you'd still do second angle DMS, and that would work for you. Okay? But in this case, we got an error. Okay, now I want to talk about, we're going to have a way to deal with angles that are greater than 180 or greater than anything, all the way around the circle, all the 360. So we're going to put an angle. What the heck is an angle anyway? An angle, by definition, is the union of two rays with a common endpoint. Okay? Let's look at that. There's one. Come here. Okay? Now if we take that common endpoint, the corner of the angle, if you would, and put it at the origin of a standard graph. That's where I put it, at the origin there. We'll do that for a bunch of them. Okay? That's called in standard position. Okay? We line up the, there's your angle. Okay? Now I'm going to line up, it starts at the initial side. I'm going to line that up along what is the x-axis. Okay? And wherever the other one ends up, that's where it ends up. Okay? It's going to open up, and that other side is called the terminal side, because that's where it terminates. That's where it ends. Okay? And that's called positive rotation. It's actually opening up in a positive direction. Okay? Let's look at another one. Okay? Take an angle, put it at the origin, lay it flat on the x-axis there. Okay? And there it goes. It opens up in that direction. Okay? That's called, it's where it starts, the initial side, which is on the x-axis, and the terminal side is where it ends. Okay? Once again, we're going to call that positive rotation. And what other options are there here? Okay? Well, how about this one? Okay? What if it goes in that direction? Well, that's the opposite. Okay? It's the opposite direction. We're still starting with this side and ending with this side. The only difference here is we're going to call that negative rotation. And that's kind of confusing because if you think about it, that's the clockwise direction. That's what we would normally call positive, I think. Okay? But it's just the opposite when we talk about angles. That's the, if you go clockwise is negative and counterclockwise is positive rotation. Okay? We'll look at another one. Now this one, let's see. That's the initial side, and that's the terminal side. If you think about it, there's kind of several ways to get there. You could go in the positive rotation or you could go in the negative rotation. What's the negative rotation going to look like? Well, I'm going to go here and here, and it's going to open up in that direction and start at the initial side and end up at the terminal side. And you might say, why would I do that? Why would I do that? Well, you have to go that way sometimes when you can't go the other way. Okay? And we learned that kind of when we were talking about the surveying example. Okay? Sometimes you have to go whichever way is available to you. Okay? Let's look at angles that are, quote, coterminal. That means they end at the, well, they all begin at the same place. Okay? They all begin at the x-axis there. So they're coterminal if they end at the same place. Give you an example. Okay? This initial side and this terminal side, if I talked about this angle, we'll call it, what is it about? It's about 110 degrees, say. Okay? Say it's about 110 degrees. We know all the way around the circle is 360 degrees. Okay? Oh, son of a gun, it is 110 degrees. Okay? Well, we could say that a positive 110 degrees is the same as, what would it be as negative? Okay? How far would I have to go in the negative direction to reach 110 degrees? Well, I know the whole poopsie is 360. So what's the rest of it? What's 360? Let's see, 360 minus the 110, if you go all the way around that direction, is, we call it, would be 250, but it's in the negative direction, so we say negative 250. Okay? So we say that positive 110 degrees is coterminal, or ends at the same place, with negative 250 degrees. Okay? Let's look at some other coterminal angles. Oh, we know what this bad boy is. This is 90 degrees. Okay? In the positive direction, he's 90 degrees. Okay, starts with initial side here, and he ends with a terminal side there. Okay? Remember that the full circle is 360. Okay? What would 90 degrees be the same as? Well, let's subtract it from 360. What's the other way around? Okay? Well, 270. 360 minus 90 is 270. But we say negative 270 because we go in the negative direction. Okay? What if we talk about going more than 360 degrees? More than 360 degrees. Let's look at an angle. Okay? This one here, we could go in the positive rotation, start here and end here. And that's, you know what it is? It's 45 degrees. Just that, boom, that's it, 45 degrees. What if you wanted to get fancy and go, we could end up at the same place. I'm going to try and end up at the same place, coterminal. Okay, I'm going to go all the way around. You say, boy, that's stupid. I'm going to go all the way around, and I'm going to end up there. I still end up at the same place. Now, what measure is that angle? It's more than 360. I went more than all the way around, right? Well, what is it? It's going to be 360 plus 45. Hopefully you can do it in your head. 360 plus 45 is 405 degrees. So we say that 45 degrees and 405 degrees are coterminal. They begin and end at the same place. Okay? We could do the same thing with a negative of that. Okay? What would be the negative coterminal? There's all kinds of coterminal angles. Okay? We'd subtract 45 from 360, and I get the 315. So we could say that 315 is, negative 315 is coterminal with 45. You're going to have to do that on your homework. Okay? Now, why would you do this? Why would you do this? Okay? The reason we would do these coterminal angles, why don't we just go, as I said before, there might be you can't get there this way, so you try another way. But with a lot of times, it matters not in an application problem where you went. Of course, it matters where you went, but it matters more how you got there. Okay? I think, for instance, a diver. Okay? Now, the diver, we know where they're starting off. They're starting off on the diving board. And we know, hopefully, where they're ending up. They're ending up in the water. Okay? What decides that gold medal from the has-been is what they do between there. Okay? If a diver does a 3.5, well, you're probably going to get the gold medal if you do it well, if you don't belly flop. Okay? That's 3.5 rotations on your way down. Okay? As opposed to maybe 2 rotations situation on your way down. They still begin and end at the same place. So how you got there is critical in that situation. What about, I'm always thinking about sports. What about this guy? Okay? You know, skateboards, when you do your jump, you're going to get a higher mark from the judges if you do a full rotation in the middle of it. Okay? Now, I don't know anybody that can do more than a 360. Okay? But a half, you know, maybe you can. Okay? I know some people in figure skating certainly can. In fact, nowadays, I think in figure skating, if you can't do at least jump in the air and do 3 rotations, you're not going anywhere. Okay? So it really matters a lot of times how you got there. Okay? It doesn't have much to do with science. Okay? A lot of times in an application, this multiple rotation idea, we're thinking about not as much how we got there, but how long it took us to get there. Okay? For instance, I'm thinking of coterminal orbits. Okay? Once again, all the way around the Earth would be 360. Okay? You ever hear like when a space shuttle is going to land, they say, well, you know, on the news, they say, well, it's going to land either at 6 p.m. or maybe it's going to land at 3 a.m. tomorrow, or maybe it's going to land at 4 p.m. tomorrow. And there's all these different times. What's going on there? Well, if there's bad weather, it can't land. What do they do when they can't land? This thing, you need to remember, is rocking and rolling. It is moving very fast. It's not like they can put the brakes on and go, well, let's just turn around and we'll come back later kind of a thing. Okay? What they do is they keep in the same direction and they come back later. How do they come back later? They go around the Earth and come back. Okay? They kind of, say you want to hit Florida and he missed. Don't! Okay, you want to hit Florida, he went by, up. Now you're going to have to go back around again and find a coterminal angle, add 360 to it, and maybe land tomorrow morning. Okay? Now that's when your target is Florida. Okay? Where they all take off and land, perhaps. What if your target is to meet up with a satellite? Okay? Well, that satellite might be going in the opposite direction. Okay? Now you can see perhaps where negative angles would be, and perhaps where they have to meet, it's going to be important that for them to meet, that they end up at the same place, that they're coterminal. Okay? So this will be of use when we get into some science problems. Okay? Okay. Let's switch to circles. Okay? Well, we're talking about circles a little bit, but there's some vocabulary I'm going to use for circles. Okay? First of all, we've got a circle. What is this? What is this thing called? I'm going to be talking about it. That's the diameter. Okay? It's a segment that goes from one side of the circle to the other. Now, you can have many of those, okay, but this one's special. This one goes through the center, okay? Anything that goes from one side of the circle to the other and goes through the center is called the diameter. You'll need to know that, okay? Now, half of the diameter, something that goes from the center out to a point on the circle, is called the radius. We're going to be more interested in that, actually, in our discussion, okay? And there's one other thing out here. That's all the way around, okay? That's called the circumference. Okay? Now, interestingly enough, if we stretch that circumference out, I just stretched it out, okay? Stretch that circumference out. If we take a diameter and lay it next to the circumference, there's one of them, put another one out there, and add them up, there's two, and add one more diameter, you say, ooh, that's real close. You might say that the circumference is real close to 3 times as long as the diameter. It's real close. And back, I'll tell you what, back in ancient days, they thought certainly it's 3, certainly 3. Do you ever see in history how the number 3 comes up all the time? It's like there's three-headed monsters, 3 crosses, 3 days, 3, everything is 3, because they kind of almost worshipped 3. Well, along comes this guy Archimedes, and Archimedes says, hey, that's not 3, there's a little schnicky here. There's a little bit more, okay? And guess what they did to Archimedes? They cut his head off. Okay? You're not allowed to go against the what we worship kind of a deal. Anyway, but it is a little bit more than 3 times. The circumference is a little bit more than 3 times the diameter. You know, if you look at some of the older buildings, even if you go back to Rome or whatever, many of them are still standing, which means they knew how to build really well, but none of the circular ones are still standing. You don't see any, people say the Colosseum. The Colosseum's not a building, it's a hole, okay? But all the square ones, a lot of them are, well, not all of them, but many of them are still standing. The circular ones, none of them, because they used 3. They did it wrong, okay? The number that you multiply is a little bit more than 3. In fact, we have a name for it, okay? The number that you multiply, or the ratio between the diameter and the circumference of any circle, is called pi. It's a little bit more than 3, and it's a hard number to write down. In fact, it's impossible to write down. It's irrational. 3.141, all kinds of crazy numbers, okay? So rather than write it down, we come up with a symbol for it, pi. Okay, so we don't have to write it down. For instance, if the diameter of this was 6 inches, what would the circumference be? Well, it would be 6 inches times pi, okay? We would write 6 pi, or 18.849. Where are you getting 18.849? 6 times pi, which pi is 3 point and a little bit more. 6 times 3 and a little bit more would be about 18 and a little bit more, okay? And that's how you would figure out the circumference of something, okay? Now, this is important to us, why, when we're talking about angles, okay? Well, if we talk, let's make things simple here. If we talk about what's called the unit circle, okay? The unit circle, what's the unit? The unit is, the radius is 1. We're going to make life easier. We're going to make the radius 1. Okay, which means the radius is 1, which means the diameter must be 2 radii, which would be 2. Okay? Well, if the diameter is 2, what must the circumference be? What's the magic thing we do with the diameter? Well, we multiply by pi. So in a unit circle, all the way around, the circumference is 2 pi, which is going to end up being 6 point something. Okay? So that's what we care about, and I'll show you why, because this is going to be a new way to measure angles, okay? Another way. This angle right here we know is 90, but there's another thing we can call it, okay? If 360 is 2 pi, 360 all the way around is 2 pi, what is 180 degrees? What would be another way of naming that? Well, it would be 90 degrees. Think about it. How many pi is that? What would be 60 degrees? How many pi is that? 30 degrees. We can name them all in a different way using pi. Okay? Pi, well, let's do it. 360 is 2 pi. 180 is half of that, 1 pi. Okay? Is that what you guessed? 90 is a fourth, 1/4 of the 360, 1/4 of 2 pi is a half pi. Okay? And you usually write pi over 2, a half of pi. Okay? That's called radian measure. Okay? When you're measuring in terms of pies. Okay? 60 degrees would be 1/3 of 360 degrees, which would be, would be 1/3 of 180 degrees. And 180 is 1 pi, so 1/3 of that would be pi over 3. 30 degrees would be 1/6 of that, 1/6 of the 1 pi. Okay, now how about this one? This is a tough one. What would 270 degrees be? How would I do it? What if I didn't give you nice even ones like that? What are you going to do? Well, the answer to this one is 3 pi over 2. Where did we get that? Okay, here's a way to do it. Okay, I would take 270, divide it by 360, okay, because that's how much of this thing is. 270 divided by 360. And remember, the 360 is 2 pi. Okay, so I'll divide it and then remultiply 2 pi back. So I'm actually taking 2 pi out and putting it back in, 360 being the same as 2 pi. I'm dividing it, then putting it back in pi language, if you would, because 360 is the same as 2 pi. Now let's cancel. Let's see. 270, they're both divisible by 90, right? So I'll take a 3 here and a 4 here. Okay. Let's see. Anybody else can cancel? How about the 4 and the 2? I'll cancel him, and I'll get a 2 here and a 1 there. Now let's see, I'm going to multiply out, and hi Mom, that's what I got, 3 times 1, 3 pi over 2, okay? So basically you put the number over 360 and then multiply by 2 pi. That's the way I do it anyway, because I remember that 360 all the way around is 2 pi, okay? Okay, now it's important to note, as we've been all day, all this class, we've been changing the mode on a calculator from radian measure to degree measure. And when we talk about pi, that's what we're talking about, radian measure, okay? Pi over 2, what are we talking about there? Are we in degree? When they say pi over 2, you should know right away that we're not talking about degree units. We're talking about radian units, okay? Because pi gives you the hint. If you think about it, pi is actually 3.14 something, okay? Don't get crazy about decimals. If it was degrees, pi over 2 would be half of the 3.14, which would be, 1.57. You know what? A degree is a teeny little thing, okay? That would be 1.5 degrees, that little picture there. That's certainly not right. We know that pi over 2 from our previous example is 90 degrees, okay? So as soon as you see pi, my point is, as soon as you see pi, you know we're talking in radian measure. Okay, you should be anyway, okay? Now let's do some calculator operations, okay? You can see how important it is to check that you're in degree measure or radian measure, because you're going to get totally different answers, okay? Before we do that, I want to make sure that you remember where these buttons are. The mode button we've been using all along, okay? The second button, we've been using that. And the angle button, we've been using that. We're going to use these. There's a new button, though, okay, to save you some typing. The pi button. There's actually a pi button, okay? It doesn't say pi on it. You'll have to hit second and then pi to get it, okay? But find it on your calculator now, because you're going to be using it for the next while, okay? And I'll tell you what, turn that baby on, and let's try and do some calculation. Let me do some, and then you do it, okay? For instance, suppose I wanted to convert 120 degrees to radian measure. Okay, let me go over to the calculator and we'll do it. Okay, convert 120 degrees to radian measure rather than degrees. Okay, I'm going to turn it on. I'm going to clear it out so you don't get confused. Okay, well, I want my answer to be in radians. Okay, so I want it to be talking in radian measure. So now I'm going to change my mode. I'm going to hit mode, and now I'm going to tell it to talk to me in radian. I'm going to make sure it's not in degree mode, but in radian mode. Okay? Now it's in radian mode, and I'll clear out. Okay? Now, I want to convert 120 degrees. So I'll say 120. I can't hit enter at this point because it'll think that I said 120 radians because I'm in radian mode. Okay? So I have to tell it degrees. I can say, just for right now, I'm talking about degrees kind of a thing. And that's what I'll do. That's when I use my second angle and say, for right now, I'm talking about degrees. Now, certainly, there's no exception there. If you say degrees, you mean degrees, even though it's in radian measure. And if I hit enter, I get 2.09, and that is what 120 degrees is in radian measure. Okay? And that's how you would do it. Now you do it. Okay, let's look at full screen here and give you a chance to do it. Change your mode to radian measure. Hit your mode button and go down to radian measure and hit enter. Okay, now clear to get out. Type 120. How do you get that degree? Remember, you should know it well by now. Second angle degree. Okay, and hit enter. And nicely you get 2.09 radians. Okay? How would we do 180 degrees? Let's do that, just so you can, and let's try it. Okay? I'm going to go to the calculator. I'm going to do, I'm already in radian measure, so I'll remember that. I'm not going to check my mode. Okay? 180. Now, if I'm in radian measure, I have to tell it degrees. Okay? Second angle degrees. Now, we know what 180 degrees is. Well, I hope we do in radian measure. It's 1 pi. Am I going to get 1 pi? Well, believe it or not, what you're seeing there is 1 pi. That's what 3.1415, okay, doesn't print out. It's going to print out a decimal approximation of that. Okay, so that's what 180 degrees is, 1 pi. Okay, let's try it perhaps with 360 degrees. Okay, I'll type 360, second angle degrees. Now that 360 we know well as 2 pi, but you're going to have to be able to recognize this when I hit enter. Is that 2 pi? Well, yes it is. It's twice the 1 pi. It's 2 times the 3.1415, etc. Okay? So you've got to relax your brain a little bit to talk in 2 languages. Okay? Okay. Let's try going backwards. Let's try going backwards. Convert from radian measure 3 pi over 4 back to degrees. Okay? We'll use a calculator to do this. Okay? Let's go to the calculator. I'll do it, then you do it. Okay? Let me clear out. Now this time, I want my answer to come into degrees. So I want the calculator to talk me into degrees, so I'm going to go mode, get in degree mode. So I'll move over to that and hit enter and clear out. Okay? So now I know I'm talking in degrees, and I want to tell it 3 pi over 4. So I'm going to hit 3. I'm going to cheat a little bit. I'm going to put a parentheses. Okay, 3. Now where's the pi? Remember, you go second pi divided by 4. I think I didn't need a parentheses there. Okay, and hit answer there. And I'm going to get something pretty screwy. Okay, I wanted it to be in degrees. What I needed, since I'm in degree mode, it thought, when I typed 3 pi over 4, it thought it was degrees. So we made an error, on purpose, of course. Okay, I have to tell it radians because I'm in degree mode. So there's a way to tell it radians. Okay, I'm going to try it again. 3. I'm going to put a, oops, I keep forgetting this. Okay, 3 pi, that's the second, divided by 4, parentheses. Now I want to tell it that I'm talking in radians, and that's where you go second angle, and see the third one down? That's what that R means, radians. Okay, I'll hit enter. Now, typically people ask, why did you put the parentheses there? Well, the parentheses I had to put there because if I didn't, the R for radian would only be active upon the 4. Okay, if you look at the screen of the calculator, would only be active on the 4. Whereas it's almost like an exponent, and they kind of make it look like an exponent because it acts like that. Okay, if I have the parentheses, now the R has power over both the 3 pi and the 4, the whole schmicky. Okay, so it's important that I put those parentheses. And 3 pi over 4, is 135 degrees. So it's important that you do that. Okay? Now you try it. Let me step you through. Let's look at full screen. First thing, if you want to end up in degrees, you'll have to put your mode into degree measure. Okay? So you'll go mode, cursor down and over to degree, and hit enter and clear out. Okay? Now, type in, find your parentheses. Find your parentheses. They're right below the cosine and the tangent. Okay, find your parentheses, put that in, put your 3 and put in your pi. You'll have to do your second button to put that in. Divided by 4 and parentheses. Okay, now don't forget, you can't just hit enter now. Since you're in degree mode, you have to tell it that you're in, that this is radians. Okay, it's stupid. It's a dumb animal. Okay, so you get your R, your second angle R, then hit enter. Okay, then I guess you have to hit enter again, and you get your 135 degrees. Okay. Let me try it for 1 pi. Let me try it. You come back to the calculator and try, how are we going to change 1 pi? We know the answer is 180, but let's just do it. Okay. Let's see. 1 pi. I don't really need the 1. Okay. So I'm just going to do pi, and then second angle radians. Now I know I'm already in degree mode, so it'll switch it for me. Okay, good to go. How come I didn't need parentheses that time? Because the R is only going with the pi. Now I'm going to do one more. We'll do it for 2 pi. We know 2 pi is 360. Let's do it for 2 pi. Am I going to have to put the parentheses or not in this case? Well, I need the R to go with both the 2 and the pi. So I'm going to do the parentheses. 2 second pi parentheses. Now I need my R, my radian, second angle, go down to it. There's your boy. Okay, let's hit enter. Hopefully it's 360, and that's the deal. Okay, so it worked. Okay, you try it. Okay. Okay, I'm going to move on. What mode are we in right now? We're in degree mode. Okay, what if I wanted to take the tangent of 45 degrees? I want to show you the confusing part of this. If I want to take a tangent of 45 degrees, it's not that hard because I'm in degree mode. Okay, I'm going to do it right now. Let me take a tangent of 45 degrees. Let me clear out. Look at the calculator. The tangent, since I'm already in, I better make sure what mode I'm in. I'm confused. Let me hit mode. Now I can see I'm in degree mode. Okay. Okay. So I'll clear out. I'm going to take the tan of 45 degrees. Okay? And I happen to know that the tan of 45 degrees is 1. Okay? I just want you to know that what if I had screwed up, which could never happen, but what if I was in radian mode? Let's switch and make a mistake here on purpose. What if I was in radian mode? I'll get into radian mode. Clear out. Okay? And take the tan of 45. I'm going to get the wrong answer. Okay? Why? Because it thought when I typed the 45 that it was 45 radians, and it gave me the tangent of that. Okay? Now I can do it in radian mode, but I have to tell it what the deal is. I can do it. I can go tan of 45, but I have to tell it it's 45 degrees. Okay? How would I tell it degrees? Remember, second angle degrees. Okay? And now, even though I'm in radian mode, it's going to say, I know he said degrees, he means degrees. Okay? And it's going to give me the correct answer, which is 1. Okay? Okay, if you look at the full screen, let me try another one. I want to try to get the inverse sine of 0.5. The inverse sine of 0.5. Okay? Well, the question is going to be is, what mode do I want to be in? Well, what do you want your answer in? Okay? Do you want your answer in radians, or do you want your answer in degrees? Right now, I'm a little bit more comfortable, perhaps, with degrees. So let me make sure that I'm in degree measure. Okay? That's why we're making sure. Let me see, mode. I'm in radian. Okay? So that's a problem. So let me cursor down and make sure I'm in degree mode. Okay? And I'll take the inverse, and I'll clear out. Okay, now how do I take the inverse sine? I wanted to remind you of that. I do second sine of 0.5. Now, the inverse sign, 0.5 isn't a degree, it isn't a radian, it isn't anything, it's the answer. So I don't put anything here, okay? The important thing is I know what mode I'm in so that when I get 30, I know that's 30 degrees rather than 30 radians, okay? That's the deal there, okay? And I know I'm right because if I take the sine of 30, let me do it. Take the sine of 30 and hit enter. I get 0.5. So that's, remember the idea of inverse sines? It's the angle that if you took the sine of it, you would get 0.5. Okay? Okay. Now I want to try take the, if you look at the full screen, I want to take the cosine of pi divided by 3. Okay? The cosine of pi divided by 3. What am I talking about here? Okay? I'm talking about certainly radian measure. Okay? Because I see the pi. I smell radian measure. Okay, I see the pi. Okay, so let me switch it to radian measure. Okay, am I in radian measure? No, I'm in degree measure. Okay, so I'll go down, switch it to radian measure, clear out, and I'm going to take the cosine of pi over 3. The cosine. Now it's a little bit crazy. I'm doing an example here, just so you'll see. I'm going to put a parenthesis here, the cosine of second pi divided by 3. Okay, now why did I have to put those parentheses? Because if I didn't, it would take the cosine of pi and then divide the answer by 3. Okay? So, and I don't need a back parentheses for the cosine, but I do need those two. Okay? And the cosine of pi over 3 is 0.5, happens to be. Okay, I'm doing some ones that come out nice. Okay, and why didn't I have to put a radian measure there? Okay, because I'm already in radian mode. Okay, that's why. Okay, if I was in degree mode, let's be troublemakers here. What if I was in degree mode? Okay, let's get in degree mode. Mode. This is getting quite confusing. Okay, degree mode. And now if I want to take the cosine of pi over 3, let's see. The cosine, got to put your parentheses, second pi divided by 3. Okay, other parentheses. Now I got to tell it that that's radians because I'm in degree mode right now. It doesn't know. It thinks it's degrees. Okay, so how do I tell it radians? Second angle, kind of manhandle it, go down and say R. Okay, and I hope you can see that the R now is referring to, I needed the parentheses not only to tell the cosine what's going on, but to tell the R to refer to both the pi and the 3. Okay, if the parentheses weren't there, it would be only doing the R would only have power over the 3. So let's hit enter. And son of a gun, we get the same answer. So I think we're hunky-dinky there. Okay? Okay. Let's start graphing some of this stuff. Okay? Remember how to do graphs? Okay? Remember we had the X and the Y? Okay? Well, let's look at some points. Okay? This point, what point is that? You always do the X before you do the Y, remember? So that would be, you went over 3 and up 2. That's why it's the point 3, 2. Let's get troublemaker. What about negatives? Okay? This point here, you always do your back and forth, and then you're up. Okay? So I guess we would go back 1 to get to it, and up 1, 2, 3. That would be the point negative 1, 3. Can you count it? Back 1 and up 3. That's why. And you always do the X part first, the left to right part first, then the up and down part. Okay? It's kind of in alphabetical order. This point, what would we do as far as back and forth? We'd go back 3 and then down 2. So that would be the point negative 3, negative 2. Okay? And how about this one? That would be, always do your X part first. I don't care where you are. So we'd go over 2 and then down 1. So it'd be plus 2 minus 1. Okay? So I just want to remind you that because we're going to be doing that with angles. Okay? And finding angles in other quadrants. For instance, if we do a circle here and we consider that this was the unit circle. This is a unit circle, meaning that the radius is 1. Okay? And then take this angle Okay, to find the sine, cosine, and tangent and all these various trig functions, I need a triangle. So I dropped, from that critical point there where it hits the circle, I dropped a perpendicular, a line. Okay? Now, what point is that? That's the point. Like any point, we'll say x, y, over x and up y. It can be any number. Okay? Meaning that this distance is x and this distance is y. Okay? And of course, we have a right triangle. Okay? So that means for this angle, the opposite is y, and the opposite leg, the one it would bite, and the adjacent leg is x, and the hypotenuse, so that's easy, the hypotenuse is 1, because it's always 1 in a unit circle. That's why we're making this a unit circle. Okay, now let's talk about the functions. The tangent, remember you were supposed to memorize these, the tangent would be the opposite over the adjacent leg, okay, which would be y over x. Okay, so in terms of graphing, the tangent could be thought of as y over x. The sine could be thought of as opposite over hypotenuse y over 1. The cosine could be thought of as x over 1, adjacent over 1. Okay? So we can do this with in graphing. Okay? Now if we move to the second quadrant, if we have an angle like that, we still need a right triangle. Okay? We still have our 1 for a unit circle. What we're going to do is use this angle. Okay? The signs are going to change. We're going to do that because we have to have a triangle to do trigonometry. Okay? We'll call that the reference angle, the angle that we use to get the answers. Okay? We'll drop our perpendicular, so we have a triangle. Okay? And there's our point. But our point, remember now, this direction, x is negative. Okay? We're going back. We still have a positive y. Okay? Negative x, positive y, and our 1 for the hypotenuse. There's your right angle. Okay? What's the tangent in this case? The tangent is going to be the same as the opposite over adjacent. So it's y over x, but it's negative this time because a positive divided by a negative. Okay? The sine is going to be opposite. The sine's the same, okay, because it's still in the positive y direction. Okay? And the cosine is negative. Okay? Because it's negative x over 1. Remember, adjacent over hypotenuse. Let's look at it in quadrant 3 quickly. Got this big angle here. I'm going to use that reference angle, so I'm going to pull a perpendicular up. Okay? Let's see. I got both of them being negative. So this will be negative and this will be negative. This time the tangent will be opposite over hypotenuse, negative y over negative x. Well, let's cancel and end up being y over x. So it's the same in quadrant 3. Okay? The sine will be negative y over 1, the opposite over hypotenuse. So that ends up being negative. And the cosine ends up being negative as well, because it's negative x or adjacent over hypotenuse. Okay? Let's look at it in quadrant 4. Now in quadrant 4, let's see. The point is in a positive x and a negative y. Okay? So there's your x and your down y, and there's your right angle. And of course, you still have your 1 for the unit circle. So let's go through the tangent. The tangent will be opposite over adjacent, which will be negative y over x. Okay? The sine will be opposite over hypotenuse, which in this case is negative because the y is negative. And in this quadrant, the cosine is actually positive. Okay? So we got positive x over 1. Okay? Now let's talk about it. What if we have a terminal side of 0 degrees? I got about 10 more things. Okay? Terminal side as 0 degrees we measure. Okay? Well, this time it's a little bit screwy. Our point is going to be xy, but in this case, x is 1 because it's the same as the, it's the same as the hypotenuse. It's a teeny-weeny little kind of flat triangle is what we've got going here. Okay, and y is nothing. Okay, so we've got a triangle that's kind of caved in. Okay, so if you try to find the tangent of 0, which is what, 0 degrees, the opposite, or the y, would be 0, and the adjacent would be 1. And the tangent of 0 degrees, that's why the tangent is 0. Okay? The sine, once again, involves the opposite, which is 0 over 1. 0 over anything is going to end up being 0. The cosine is going to be, let's see, the cosine is going to be the adjacent, which is 1, and the hypotenuse of this very flat triangle is also 1. So the cosine of 0 degrees ends up being 1. Now that's really important at this point. When we go to graph these things, you're going to, hopefully you'll remember that the sine starts off, when you start at 0, we start graphing at 0, the sine starts off at 0. Okay? The cosine doesn't start off at 0. The cosine starts off, well in this case the cosine starts off at 1. We'll find out in the future the cosine starts off at its highest point. Okay? So remember the sine starts off at 0 and the cosine doesn't start off at 0. Just think of that for right now. Okay? That's how we'll know the difference between the two. If we have an angle of 90 degrees, okay, what are the sines involved here? Okay? Well, basically what we have is a tall, very flat triangle if we're talking about putting it on a graph. Okay? The point in this case is the point xy, but in this case we went over none and up 1. So it's 0, 1. And if we put in the same x's and y's, the tangent of 90, this is going to be a little screwy now. Okay? The tangent of 90 is going to be the opposite over the adjacent. The opposite is 1, that is very tall, thin triangle. The adjacent is none. What is 1 divided by 0? Some people will tell you it's undefined. When we talk about this graphically, 1 divided by 0, we're going to call it infinity. Okay? It goes very high. Okay? 1 divided by 2, for instance, is a half. 1 divided by a lower number than 2, 1 divided by 1 is 1. Okay? We're getting higher. It's getting higher. 1 divided by none, it gets so high it goes to infinity. Okay? It's kind of crazy to think about. A lot of people say, heck with it, it's undefined. Okay? But that's what's going to happen there. The sine of 90 is going to be the opposite over the hypotenuse. What's the opposite in this case? The opposite of this very tall, thin triangle is 1, and the hypotenuse is 1. So the sine of 90 is 1. And the cosine is going to be the adjacent over the hypotenuse. The adjacent is nothing. Okay? It's a very tall, thin triangle. And the hypotenuse is 1. So 0 over 1 is 0. Okay, well at this point I'm sure you're saying, I've learned quite enough, thank you very much. Okay, so I'm going to have you do homework number 4 now. Look in your syllabus to find out what that is. And if you have any trouble, don't forget, you can email me from the home page, or you can view the class animation should you choose that on the home page as well, or you can call me at home. Thank you very much. See you next time.